Hello, everyone, and welcome to the course of Cloud Computing for the Winter 2023 semester. My name is Amartya Sen, and I will be your instructor for this course. In this video, what I wanted to do is basically walk you all through the syllabus about the different aspects of student deliverables that are there for this course, what are the grading scales and things like that, and draw your attention to a few of the action items that are due in about 2 weeks' time, which specifically relates to group formation and topic registration for two of the different tasks that you have for this course that will be running probably across the entire length of the semester and almost half of the length of the semester. So after that, I will discuss the course overview. That is how this course has been designed, what are the different learning modules that we will be covering, what you will be learning. So basically all of the different topics of interest that are there. And then finally, we will wrap up today's video with some of the initial discussions about the background of how this course came into being. Not this course in particular, but how the concepts of cloud computing came into being, what are the background, what are the fundamentals and stuff like that. So we will be basically covering about discussing some of the basic terms and definition that builds the foundation as you move towards cloud computing, okay? So moving on to the syllabus, first and foremost, as you all know, this course has two different sections. Well, before even it has two different sections, it is actually a process course, right? So we have 40 to 40, which is basically the section for undergraduate students. And then we have the grad version of this course, which is 50 to 40. And both of them are for cloud computing, essentially. And for each of these courses, or for each of these class listings, we have two different sections, okay? The first one is basically a hybrid section, and the second one is a fully online, or otherwise I like to call it an asynchronous section, okay? So the simple one, which is the fully online one, is when I will be providing the recording of the lectures as we move forward with the course. And then students who have opted for the fully online section, they will go over the course materials at their own time, on their own pace, and they will be completing all the different assignments and activities that are there for this course to get graded, okay? And then the hybrid, the way it is designed is that there are 2 meeting days every week for this particular course, right? As we move forward with this semester. One of those meeting days, weekly, we will have in-person classes, and that in-person class will be taking place in Engineering Center 254, room number 254. And then the other day, every week, we will have synchronous online classes that will be held via Zoom during the class hours itself. Okay, so the class hour essentially is from evening 5:30 to 7:17, give or take 7:30, right? So one of the days, which is basically Mondays, we will have in-person classes in Engineering Center 254. And then on Wednesdays every week, between the times of 5:30 to 7:30, give or take, we will have the classes in a synchronous online fashion through Zoom, okay? And as I've already discussed this in my announcement, if fully online students wish to attend in person or during the synchronous online classes, they're more than welcome to do so. You don't have to change your enrollment. You don't have to change your sections. That is not a requirement on my part, okay? And similarly, if you're a hybrid enrolled student and some days you may not be able to attend the class hours, right, either in person or online, then please make sure that you send me an email, just notify me so that I don't wonder why you're missing for an extended period of time, that you are attending the class as a fully online student, right? And overall, all the classes will be recorded, okay? Whether it is in person, synchronous, online, and the recordings will be available to all students, regardless of which section they have enrolled in, right? But again, don't take the recording as a reason to kind of fall behind in the course or take things lightly, okay, or take things for granted. Please make sure that you stay on top of the materials to make sure that you are having the best possible learning experience from this course, and please stay on top of the assignments because they are lengthy in nature and they are to a certain degree challenging in nature as well. So if you slack off for too long, 2 weeks or more and stuff like that, then you are definitely going to fall behind, and that is going to impact the performance in this class, your performance in this class, right? So please keep that in mind as we move forward into the semester. Okay. So course description, I'm not going to read that. My office is Engineering Center 322. I have not specified any specific office hours as such. So what you can do is send me an email, whether you want to meet me in person, whether you want to meet me online through Zoom. I don't have an issue with either of them. So just reach out to me that you want to meet me, tell me the times that works for you, and then we can figure out something that works for both of us, right? And then we can meet for an extended period of time, or as long as it is required to address the doubts and issues that you might have, okay? Learning outcomes, you can go over them. I'm not going to read them one by one. There is no required textbook for this course. If you still need something, then there is something that is suggested here. So you can look this textbook up. You don't necessarily have to buy it. I believe a PDF copy of this textbook is available. If you are proficient in Google search, you should be able to acquire one for yourself. Otherwise, you can rent it from Amazon if that's what works for you. What is required, though, is since this class will have a lot of demo with respect to understanding the fundamental services of AWS, right, Amazon Web Services, a credit card or debit card is required if you plan to, which is strongly recommended, do those demos by yourself as well, which is the things that I'm going to show you in the class, right? So based on prior experiences, the charges to your credit and debit card is going to be somewhere around the $5, give or take, right? So, but no more than $15. It's never going to reach that point because it's pretty cheap. So that is something that is required for this class. So that is one place that you would have to spend a little bit of your money. Okay. So coming to student evaluations, just going to the overview, we have these 1, 2, 3, 4, 5 set of evaluation criteria. Okay. So the first one is a very simple one. We have a take-home exam. It is individual in nature and is worth 50 points. And later on, when I, right after this, talk about the setup of this course, the topics of interest, you will see that the take-home exam will be assigned more or less right after when we finish the second learning module, right? So the take-home exam is conceptual in nature. It is to reinforce the knowledge of the fundamentals and the theories that is around the cloud computing concept. Okay, so that is what the take-home exam is going to be all about, right? So you will be assigned the exam. You're free to refer to any resources at your disposal. Just make sure that you cite those resources. That is what is mandatory. Once the assignment is opened in Moodle, you will have further instructions as how you need to prepare your answer report and stuff like that. And you will be given 7 days to finish. That's a hard deadline. And once you are done, just submit it on Moodle, right? Thereafter, you will have 5 quizzes. Now, the nature of these quizzes is to draw your attention to the key concepts of each learning module, okay? And in a few minutes, we will talk about these different learning modules and how I've set this up. So after you finish each module on Moodle itself, you will be getting a quiz, okay? And these quizzes are going to be of very short answer type questions or multiple choice questions, okay? And you will not be taking more than 15 minutes to finish any given quiz, right? That's how the quizzes will be designed, because the whole idea of this quizzes is to have like 2 to 3 questions, but no more than 5 questions to just highlight the key important things of each learning module, right? So at the very basic, if you don't remember everything, as long as you understand or recall what is the most important thing in each module, then that will be a good start, right? So that is how the quizzes have been designed, and that is what will be assigned to you when we finish each and every learning module. As far as deadline is concerned, there is no set date for the deadlines of quizzes, okay? So what that means is that after every module finishes, I will be opening a quiz on Moodle and you'll be answering the quiz on Moodle itself, right? And your job is to make sure that you finish all the quizzes by the end of the semester. Now, I know that's a very open and a very big deadline, but it is recommended from my side that you take the quiz and you finish it just as we finish with a given learning module, so that you don't forget what are the important things and it stays with you as you move forward with the course, right? Because one learning module builds on top of the previous learning module, right? So if you wait to take the quizzes till the very last day of the semester, then the whole purpose of the quizzes are kind of defeated, right? But at the end of the day, I'm not going to micromanage you. I'm not going to tell you, hey, take the quizzes. I will just give you a recommendation. It is up to your decision making as to when you want to take the quizzes, right? Okay. So the other two things are where basically the brunt of your evaluation points or grade points are kind of concentrated towards, right? And both of these are group-based activities, where the first two were individual activity, the rest of the activities that you have are basically group work, okay? So the first one that we have is a research paper presentation. So what this entails is basically there is a list of research paper presentation topics, which is composed of all the classical academic research publications, peer-reviewed publications with respect to the cloud computing domain, all the research that has happened, right? So as a group, you need to select one topic and then prepare a presentation on that, a thorough presentation, which will range for about like 40 minutes. And we will talk in details about this task. I'm just giving you an overview of what it contains right now. And then once you do the presentation, you will prepare a very short report. By short, I mean like 2 pages long, right? And then the division of the points there will be 75 points for the presentation, and the presentation will be pre-recorded in nature. So just like I'm giving you the presentation right now, by recording the lecture, you will be doing the presentations in the same manner, right? You'll be recording the lecture and sharing with me the link of your recording in the report, right? So we can see your presentation, evaluate your presentation, and then give you the grades accordingly, okay? Other than that, there is a semester-long research group. And by the way, the research paper presentation task will be for about 4 weeks. So from the time that you're assigned, you will get about 4 weeks time to prep your presentation and your report, okay? Research project is going to go on for the entire semester, and it is divided into 2 different phases, okay? And again, after the research paper presentation task, I will also delve a little bit in depth into what this project is about and talk about the different topics that are there, right? So for now, what I'm going to tell you is that you have 2 phases. It's going to run for the entire duration of the semester, 100 points per phase. And at the end of phase 2, which is basically the end of the semester, you will again have to prepare a demo, a recording, explaining your project, your outcomes, your conclusions, and your discussions, and so on and so forth, okay? In addition. And then finally, there is a task which will be opened probably towards 2 weeks before the end of the semester, which is basically a self and peer evaluation for your group works, right? So wherein you will be evaluating yourself, and in comparison to you, how your group members have performed and contributed. And that will be kind of taken into consideration when giving the final points for your group work, okay? So there will be a self and peer evaluation for your research paper presentation, and there will be a self and peer evaluation for your entire research project, totaling to about 30 points. So this essentially means that nobody's going to get a free ride at the expense of somebody else's hard work in the group, okay? So just because if somebody pulls the entirety of the weight and does all the hard work and gets the point for it, the others who have not contributed for it are not going to get the same points, okay? At the end of the semester, I will be kind of reevaluating everybody's contribution to the group work based on the self and peer evaluations, and then I will be revising their final grades for project and for paper presentation and stuff like that, okay? So please make sure you don't take each other for granted. Please make sure that you all do your part, and please make sure that you communicate and work hard for your group work, okay? So as far as the grading scale is concerned, you're following the basic grading scale that OU has provided. There's no changes to that. You can read through this scale, and then you can compare it based on the points that you receive as the course progresses, and everybody will be aware of where they stand and what kind of grades they will be receiving at the end of the semester. There should not be any confusion regarding that. It's pretty straightforward, okay? But at the end of the day, please remember that whatever your final percentage score is, you'll be getting the letter grade equivalent to that percentage score. There will be no grade boost given at the end of the semester, no matter how short you are from the next letter grade. Even if it is 0.01%, you have received what you have received based on your performance, right? So please don't send me emails at the end of the semester asking for, a grade bump or a grade boost for the next letter grade, right? So just make sure as you progress through the semester, you know where you are, and make sure you work accordingly to get what you want to get, right, in terms of your final letter grade. All right. So the rest of the syllabus, pretty straightforward. You can just read them. I'm not going to read them out. It's some of the basic policies that are there that we follow at Oakland. And make sure that if you have any questions, you can just reach out to me regarding those matters. Towards the end of the syllabus, we have another section, the tentative course schedule. The whole idea of this is to give you the idea of the time window of when the assignments will be assigned, okay? Not the final date, but the tentative time window, right? Because given the pace at which we make progress through this particular course, sometimes we might be lagging a little bit behind from the tentative course schedule, probably about, a week's time and so. So this is for you to kind of set yourself up mentally that, okay, around the time of, let's say, for example, January 23rd, we have something which is due, right? Along the time of this particular week, exam will be assigned if everything is on track, right? So this is what the whole idea or the purpose of the tentative course schedule is to kind of mentally prepare yourself that around this time window, you might be getting some assignment, you might be getting a particular assignment, and this is when it will be due, okay? So as far as the action items are concerned, you have to keep in mind that there are two important things, actually three, is you need to submit your group member names, which is due by January 23rd, 11:59. Now, please make a note here that if some people do not submit their groups, right, I will be assigning them to a particular group by combining all those who have not submitted their names. The minimum student requirement for every group is 3 students, and the maximum is about 5. Okay, and we'll talk a little bit about that when I move to the Moodle portal in a second to draw your attention to those activities which are actually open right now. Okay, and after that, the other two, after the group member name submission that is due, is basically right after that on the Wednesday, you will be required to submit the research paper presentation topic and the research project topic that you would like to work on as a group, okay? And please remember that if you do not submit this topic name by the due date, then you will be losing 2 points for every 24 hours delay until 96 hours. This is 4 days. So you can lose up to 8 points for the original assignment. So that means if you have not submitted a topic for your research paper presentation for 4 days over the deadline, you would by default lose 8 points from your research paper presentation task, and that will be evaluated based on 92 points instead of the original 100 points. The same goes for your research project as well. So please keep that in mind. That is the immediate deadline that is up and coming in about 2 weeks' time, okay? Well, actually more than 2 weeks. It's about 2 weeks' time. And after that, you can take a look at the different assignments that are there. So the exam one is here. You'll get 1 week for that. Research paper presentation and report preparation is about 4 weeks' time. The phase 1 for the research presentation, research project, you'll be getting about 6 weeks' time. And then similarly, you will get about 6 weeks' time for completing phase 2, which is the hard deadline. Essentially, this is the last day of the semester. So if you miss this deadline, there is no late penalty situation anymore. You will just receive a 0 if I don't see anything after the 26th of April, which is essentially the last day of the semester, okay? So another thing to note, since I just forgot about that, is the late penalty policy. So as far as late penalty is concerned, if you're late more than, if you're late 24 hours after the deadline, you will lose 10%. And if you're late by more than 24 hours after the deadline, but before 48 hours, that is the second day of late submission, you lose 25%. And there will be no credit thereafter. Now, of course, there will be exemptions to the late penalty, depending on the situation that you are in. because sometimes there can be unforeseen situations. You can have family events, family emergencies, something like that might happen, right? So if that has happened, or if that is going to happen, well, if other than that, and even more than that, if you know that you're going to be late, right? If you have a clear idea that let's say you have an exam for another class, you might not be able to work on this assignment or whatever the assignment is, right? So please make sure you communicate that to me ahead of time. If something is foreseeable, if it is an emergency, of course you cannot tell me beforehand. But if it's something that you know that you are not going to make it, then tell me, at least try to tell it to me 2 to 3 days before the deadline, not on the day of the deadline, not a few hours before the deadline. Don't do that, right? Don't start your work right before the, 1 day before the deadline, thinking that you would be able to finish it, and then something happens and you cannot finish it. That's not an emergency, okay? If you start early, but you realize that things are piling up on you and you won't be able to finish it, you won't be able to schedule your time, no matter how hard you try to optimize it, then if you tell me, then I can try to help you out in the situation, depending on what the situation is, right? But any kind of request for exemption on a short notice, I will not be able to entertain that. Okay, so please keep that in mind and try to communicate with me as early as you can if you know a situation is unavoidable. Okay. If you lose your work because you didn't keep backup, if your computer crashed, that will not be considered as an exemption clause. Okay. Please make sure that you have multiple backups. Your backup should not be your main device. I keep on saying this, but people keep on doing this for some reason. Backup should not be kept on your local device or the device that you're working. Backup should be on some cloud drive, Google Drive, OneDrive, Dropbox, whatever it is that you work with, right? So have multiple backup copies and stuff like that, okay? Always have an alternative plan that in case of failure, what are you going to do? So these things, please make sure that you have already figured out before you move forward with the course. All right, so that takes care of more or less the important aspects of the syllabus. So before we jump into the design of the course and the topic of interest, let me just talk a little bit about the Moodle setup that I was telling you. And essentially, okay, so this is your Moodle course page. This is what you should see on your site as well when you log in. So most of the stuff in the course overview section is basically the important and key aspects of our syllabus itself, okay? We do have a TA now. I will share the email, and once I confirm her office hours as well, I will let you know. The location is listed as Zoom for the time being. Okay. So all the materials that I just talked about and I'm going to talk about is basically available in the general section of your Moodle course page. There's also a breakdown of the students that are enrolled based on whether they are graduate students, undergraduate students, and so on and so forth. Okay. So this was created around the 3rd of January. So I believe from that point onwards, 2 more students have enrolled and their names might be missing. But you can take a look at it. The reason why I shared it is if you have a preference that, oh, you want to make a group with only undergrad students, or you want to actually make a group with, grad students and vice versa, then this will give you some, initial idea of who to contact and who to reach out to if you're not familiar with anybody in this course. I know some of the students here are returning students. I'm familiar with some of them. So they're probably going to make a group depending on how their experiences was from the last time, right? So, but there are also some new students, right? And for the sake of the new students, I have shared as much as the information I could gather at the beginning when I was creating this course page, right? So you can take a look at this. I don't know if students are able to see the participants. If they are, then you can check it out. The reason why I shared this document essentially is because Moodle does not make any distinction between the different sections that we have, that is the undergrad and the grad section. It does not say that if you are a fully online student or a hybrid student and stuff like that. So if that is something that you're interested to know, then you can check out this document and I'll give you an idea, okay? The Zoom link for synchronous classes is in the Zoom link section. So if you go here, essentially you can see day by day, every day's Zoom link resource that you will need in order to attend the classes online. And then on the days when the classes are in person, if you still want to attend online, or if fully online students want to attend it synchronously, then they might be able to do so using this. Okay, so coming to the group formation, here you see the group choice that we have is where you will be listing your groups. So what you need to do essentially is once you open this, okay, all the instructions are here as well, is I have created about 9 groups, right, with the idea that there are currently about 39 students enrolled in this course. So you will see 41 participants, excluding me and the TA. You have 39 students. So if you have 5 members, that is the maximum capacity of each group. Okay. You will select a group, like each member of a particular group will select that group and then just submit it. Okay, save your choice. So every member has to do this. A single member cannot register their entire group. So what you have to do is first find all your group members, right? And decide upon which group you're going to select. And then once you select that group, just have all the members just click that choice and then save it. Okay, so do not select and enter your choices unless your group is ready. That's the suggestion that I would give. Otherwise, it's going to create chaos here because you don't have a group. You just decided, oh, I'm going to join group 1. And if everybody does that, then a fully prepared group of 5 students won't have the slot to register themselves. So first, try to find at minimum of 3 members, okay? And then select your choices. That's the bare minimum requirement to, work with this particular choice setting. So after course group selection, in order to aid the discussion about finding a group, right below this, I have also created a forum, which is discuss and find your group members. So if you're an online student, if you're not going to attend the campus, if you're not going to meet other members of the participants of this course, then please go into this forum. And I urge everybody do this for those who do not know their group at this point of time. Add a discussion topic that, hey, you're looking for a group. This is your working preference. Give some information about yourself, that you maybe work full-time or you work part-time. This is your availability. This is the amount of time that you would be able to invest in a particular week. These are your strong points. These are your weak points. Maybe you're good with a particular language and stuff like that. Maybe you have prior experiences with research and stuff like that. Share this information. You have about 2 weeks time. So start early. If you start looking for a group member 1 day before the submission deadline, you are obviously not going to make it, right? No student is going to sit there and monitor that. Okay, so make your posts now. That is a very strong recommendation for those of you who are not familiar with anybody else. And monitor this post. If you see somebody, talk to them right now. This is what the time is for, to get a discussion started, getting to know each other, and then formulating a group on your own terms, rather than having me forcibly create a group and then later on you having some kind of compatibility issue with your group member. You don't want to go to that point. So you have the time now, use it properly, and make sure that you at least try and end up finding yourself a group that you are okay with, or that you have agreed to. Okay. A note there is that once that deadline passes, which is basically this January 23rd, 2023, which is basically the Monday, on the Tuesday, I will just finalize all the groups. And once the groups are created, I'm not going to change it anymore. Okay. Especially the groups that I create. So don't wait for that to happen. Please take a proactive step. Start your discussions. Okay. Reach out to your group members. Once you formulate your group, the next step is to basically select the project. So now there are 2 documents here, which is basically the data analysis project for cloud security. That is the research project, the semester-long research project that we're talking about. And then there is the list of papers for research paper presentation task. Okay, so select a topic and then go to this survey that is opened here. And then the survey basically has 3 questions, which is, what is your group number? So pick the group number that you have selected in the previous choice that I showed you. Enter the names of each group members that you have. Full names, don't do any nickname business, okay? So that I can kind of double check that this is the people who are in the same group as they have registered with their group information. with each member's name in a new line. Okay, so you have 5 lines here. That's the maximum number of group members you can have. And then write down the full title of the research paper topic that you are going to be selecting. Okay, so that is essentially for the research paper presentation topic. And the same goes for the research project topic. And once I open those 2 documents, it will make sense that what I mean by the title of the topic in a short while. Okay, so if you go to the project topic selection, you should see a similar survey, but the only thing that will change is basically, in addition to your group members and your group number, you are going to be specifying the category name. So there is a category for the project, and there's a topic, multiple topics that you can select from in each category. And so you're going to write the category name and you're going to write the topic. Okay. If there are any overlaps between the project topics, it's absolutely fine. Okay, but try to avoid overlap. So if I see that there is an overlap with the research paper presentation topic, essentially we're following the system where you have to break a tie. Is that if 2 people select the same thing, then I will try to make that nullified and have each group select a new topic. Okay, but we will figure that out. Don't worry about that. So first of all, you select your first preference. Okay, and then we will go from there. All right, so exam, quizzes, research paper, PPT, research project, everything is there. So, and then you have 5 different learning modules and then an extra module on security services that are provided by AWS. Okay, so before we move into the topics of interest, let's just go into the research paper, PPT topic and guidelines first, and let's clear that out of the picture. All right, so pretty straightforward here. You see here a set of 15 research papers. Okay, and all of these are classical research papers in the domain of cloud computing. What do you have to do is select one paper. So this is what I meant by the title of the paper. So you will select this whole thing and put that in the cell. Okay, select this paper, download the paper, okay, and read the paper thoroughly as a group. You can divide the different sections of the paper amongst each other. Typically, there are like 5 to 6 sections for every paper. And there will be 5 to 6, not 5 to 6, but like 5 group members. So it's not a big reading task, okay? And then you have to prepare a proper research presentation and then a research report, which essentially will entail a summary of the paper that all of you have read, written no more than 2 pages long, essentially detailing what the paper is about, what are the important methods, what is its novelty, what are the results, and what do you think are the pros and cons of the paper. Okay, by cons I mean what can be further improved or what could have been further improved. Okay, so the list of deliverables for it is kind of detailed here right after the list of topics that you have. So you have to create a PPT presentation that will be used for your recording purposes, and then you will have to create a 30 to 40 minutes recording, no longer than 50 minutes. Okay. Now here is a question. Sometimes I get this question that, hey, you said 30 to 40 minutes, but I have 20 minutes. Well, if you can convey the required content in 20 minutes, I'm not going to question that. Okay. So don't write to me that my video is 38 minutes long. You said 40 minutes. Am I going to lose points? No. Ask yourself that you read the paper. Does your presentation convey the information that reflects the content of the paper, right? If an audience with zero knowledge looks at your presentation, will they be able to ascertain what is going on? If the answer to that is yes, then it doesn't matter what the timing of your presentation is, all right? So this is basically just for your reference. Typically, a proper presentation takes about 30 to 40 minutes, all right? A full-length research presentation. So that is where this number is coming from. But yes, if you go above 50 minutes, then you will be in a position where I might question that why is it taking so long? Because typically it doesn't take too long, okay? But then again, don't ask that if my presentation is 45 minutes, is that okay? Yes, that is okay. It's under the 50 minutes. But if your presentation is like 65 minutes for some reason, then you need to ask yourself, why is it so long? Okay, because it shouldn't be that long. Okay, typically even a PhD defense isn't more than 50 minutes. So if you're presenting one paper in more than 50 minutes, then you need to reevaluate your presentation strategy. Okay, so that's basically what these numbers are. use that as your reference. Find the sweet spot that allows you to convey all the content of the paper. That is more important, okay? And what should you convey? Well, you should convey what the problem statement is about. You need to convey the motivation and objectives of the paper that you just read. You need to technically explain the proposed research methods, the frameworks, whatever has been proposed, okay? Technically, that's the emphasis. And then discuss the results as presented by the authors. Remember, this is not your results. So don't say we found out or we found this and that, right? It's not we, it's not I, right? They, the authors, that's the word, okay? And then finally, your own contribution to it, where you will kind of highlight what are the 3 things that you found interesting in the paper, and what are the 3 things that you think could have been improved from that paper, right? Because the paper is essentially published at this time, you're not doing a peer review. And then finally, once that is done, that is once the recording and the PPT is done, you will create a 1 to 2 page summary report. Essentially, the summary report, I have not specified any pattern as such, but you will follow the basic pattern of like 1-inch margin on all sides. You will use Times New Roman font or Arial font or font size 11 or 10, depending on whether you're using Times New Roman or Arial, and then single column with the title of the paper and then whatever content is there, right? So very short and sweet summary, right? Not an essay writing competition. So that's the 2 main deliverables: the recording and the summary, the report of your paper, okay? And you need to pre-record your presentation. You'll not be presenting this in class, otherwise we will lose a lot of class time. So some suggestions: if you know how to use OBS Studio, you can use OBS Studio. There are other recording platforms as well. The most simplest is to just create a Zoom call amongst your group members and just record that, and then share the cloud recording link. Or if you share, if you record it on your local computer, then you can put it up on Google Drive. Make sure it's publicly accessible, or put it up on YouTube, whatever you like. Okay, so that's how you can record your presentation. All right, so that's mostly about the research paper presentation task. Next, we have the project. The research project, as I specifically like to call it, and the one that took some time for me to structure the class as I was working on this particular assignment, is basically a data analysis project, which focuses on a specific aspect of the cloud domain, which is cloud security. And the reason why I did not choose from my previous iterations of this course to have an open-ended research on cloud computing is because right now, after talking to different industries, interacting with them, even though functionality and performance are still important, if something is not secure, it makes no sense, right? Given the interconnectivity that we have in the current day, if you cannot, as a developer, as a software engineer, if you cannot develop something that is secure, or if you do not have any idea about security, then your application is not going to be accepted by the wider community, right? So that's where the motivation for designing this project is coming from, right? And essentially, since most of the startups, most of the small scale, and even a lot of the large scale companies rely on cloud computing, if you go and work for them, and if you don't have any idea about cloud security, even though you are not, your cybersecurity is not your primary domain, you are a developer, you are an architect and stuff like that, you still need to know about security, right? So that's where the motivation of this particular project topic is coming from, right? It focuses on cloud security, and it combines the idea of data analysis on cloud security to kind of allow us to kind of dig out some of the key features or some of the unknown features that is not evident from the documents that are publicly available on the web, and then share that with our audiences, right? So essentially, what this assignment is about is you need to pick a topic from the list below, and I will talk about the list one by one as well, okay? If there is an overlap between the groups, not a problem, okay? You're free to select whatever topic you want as a group. If that is something that you're passionate about, go ahead. It's not the same as research paper presentation. So once you select the topic, for every topic, I have given you a starting resource, okay? It's not much, but it gives you an idea of what that topic is about, probably shares a few important documents, some initial reads. Your goal from there is to kind of find more resources, more relevant resources. Now, these resources could be in the form of academic research papers in that particular domain. industrial white papers, technical reports, news articles that talks anything and everything about that particular topic that you have selected. Okay. You then need to perform a data analysis on your resources. Okay, whatever these resources are. So it could be simple statistics. It could be different data analysis methods, sentiment analysis, clustering, you name it, you can use it, right? If you want to do natural language processing, go ahead. If you know some machine learning algorithms that you want to use it, you can do it, right? If you want to use LDA and stuff like that, go ahead, no problem, okay? But you have to decide as to what your hypothesis is going to be, what do you plan to get out of this, and then what kind of methods will be helpful to you to get this out, right? And then you need to report your findings and educate your audiences. Your audiences being me and the rest of your peers in this particular instance, right? And what this assignment is not about is me telling you what to do and how to do it, and then you executing it, okay? This is a graduate level coursework with a high level undergraduate class cross-listed with it, right? So the assignment, as I like to call it, is designed as an open world assignment. If you're familiar with this term from video games, is that you get to decide how you are going to go from point A to point B. And as a client of your project, I'm going to tell you what is that I want to see as the end goal, right? So I'm going to specify the end goal. The end goal is specified here as you go down in this documentation as some starting ideas or references as to what I expect to see. How do you formulate your problem for your project? How do you solve it? That is on you. Okay, so there is some level of uncertainty that is kind of involved in this project, right? It doesn't have the usual structure as you see in your typical, 2000 level, 3000 level undergraduate courses or some other graduate courses per se, right? It's not about that traditional structure. It's about understanding that how can you approach a problem, how can you work independently, how can you critically think for yourself, how can you work to meet the needs of your client when your client is not fully sure how it needs to be met, right? So me being your client, I'm just going to tell you that, hey, I want to know these things from the stuff. And I may not be fully familiar with that this is what I want to know. It is on you to figure out what the problem is going to be and then how to solve it and then discuss the results. So of course, as we go forward with this, you would like to meet me regularly throughout the semesters, okay? And get my feedback on your progress. So that will allow you to kind of reassess your strategies and make sure that you stay on track and you don't kind of, keep wandering in the open world and not end the game, so to speak, right? So again, discuss with me, and you can discuss with me as much as you want, right? If you want to discuss with me weekly, more than free to do so. If you want to discuss with me bi-weekly, monthly, but if you don't discuss with me at all, then it's going to be a problem because the only time you get my feedback is the final time when you're getting graded, okay? You don't want to be in that position, all right? So figure that out amongst your groups, take a proactive stand. This is an intensive task. I can tell you right away from the get-go, given the vision that I had when I was preparing this assignment. So you need to start early, okay? You cannot wait till the last moment, expect to get this done in a week's time before the deadline. You are not going to achieve that, okay? It's going to be very hard. So please make sure that you start early, work on it, have some dedicated timings that, okay, I'm going to work on this project. And this has almost 50% of your final grade, right? So if you do poorly on this, it's going to reflect poorly on your grades. So please be aware of this and make sure that you stay on point regarding this particular assignment, okay? So what are the topics? Okay, so you need to select a single topic from a single category. Okay, I have given multiple topics from each category. So the first category that we have is security with respect to architecture and components, okay? And then you have with respect to hybrid cloud security, okay? And then with respect to cloud security services management. If you're not familiar with these topics right now, don't worry. We will discuss it as the course progresses, as how it is done on AWS and stuff like that. But if you want to get a head start, then go to these resources, okay? It's an embedded link. So if you click it, it will take you to that page, read about it, okay? And you will get an initial introductory idea of what this topic is about. What does it entail? And then you need to read a little bit more because it will have some terminologies, some concepts, to explain the initial concept that you might not be familiar with. That's how you increase your knowledge, right? When you're starting from level 0, when you're starting from scratch, okay? The second category is basically assessment and audits, all right? So there's only one topic here, and that's one of the best topics, not best topics of this category, right? So here you also have, we don't want to go there right now. I have downloaded the data for you, okay, and I've shared it through my Google Drive. So essentially, you have the assessment questionnaires for cloud security that is submitted by probably like, last time I did this, it was about like 200 vendors or so, right? So they follow this structure that is known as the cloud controls matrix, and there's a questionnaire, so the answer is survey, right? So this is something that you can also look into and work on. Then there's a category of emerging technologies where blockchain as a resource to secure cloud computing. You have security with respect to Internet of Things that is supported by cloud computing, and then industrial control systems for CPS-based activities that is supported by cloud computing. So pick one of these. Then there's industry specific. If you are kind of drawn towards fintech, there is this thing that is going on right now. So how do you secure financial services, right? Do you want to learn more about the PCI DSS policies, right, for credit card industry and stuff like that? Is that something that is something that you're curious about? Then you can take this topic, right? Or if you want to do health information management, if you want to know about HIPAA, what are the privacy policies, right? How do these policies vary from EU versus Asia Pacific versus Americas, right? If these are the things that interest you and you want to work domain specific, then here is the category for you, right? Then about DevOps, right? So you all know about DevOps, you know about CI/CD. Well, maybe some of you don't know about it, but for those who have heard about it, continuous integration, continuous delivery, and how to kind of bring all that together into a single integrated pipeline, then this is the topic, and this is the security aspect of it, right? So you can choose from application containers and microservices, or you can choose specifically about DevSecOps, which is basically creating a pipeline for security, just like creating a pipeline for development, okay? So you can choose one of these topics. Then you have security services, which is about zero trust. So there is always a concept of trust, right? So in security, when you model, right, you have to establish what is known as the threat model, right? And in the threat model, you kind of create this boundary, which is known as your trust boundary. So what you assume there is that anything within the trust boundary, everything is a trusted resource, and there cannot be any kind of malicious activity within the components that are there. And anything that is outside is not trusted. And so we will apply the security policies, compliances on those things, or any kind of interaction between them, right? In the modern day, we are coming up with this new concept of known as zero trust. That is, we don't provide, or we don't trust anything. So there's no concept of a boundary anymore, right? So how do you educate your audiences regarding zero trust? What are the advances in zero trust? So things like that. So that is what this topic is about, how to dispense security as a service. Some of you who might be familiar with some of the cloud computing delivery models, right, service models and stuff like that. There is infrastructure as a service, platform as a service, software as a service. There is also the concept of database as a service, and there is more as a service as well, okay? There's also security as a service, right? So talk a little bit about that, or research about that, research about identity and access management, okay? Authorization and authentication, which is cloud key management, okay? So there are many different categories, many different topics. Just pick one topic from one category. That's all you have to do, and then research extensively in that, all right? So what you stand to learn from this assignment is, of course, you will learn about the security in the topic that you pursue. That is the most common thing that you are going to learn, right? But from a person's skill set, you will also learn about how to work in the face of uncertainty, right? That is when your problem as goal is undefined or semi-defined, and then the end requirements is provided to you by your clients, and that end requirement is somewhat clear, right? So they don't tell you explicitly like task 1, task 2, task 3, I want this, right? They don't tell you that, but they tell you that, hey, I want to know this, and then you work on that, and you go back to them and you ask them, okay, do you think that we are on track? Is this what you expected, right? So that is the kind of operation that I want you to undertake when you do this project, right? So for all those who are new to this, you will learn all of these things. For all those who are familiar with this, working in the industry and stuff like that, you might be able to resonate with what I'm trying to tell you. Working with clients are not always the most easiest thing that you will come across, right? So this will boost your confidence as you move forward in your career in terms of independent working, critical thinking, and problem solving. Okay, you will also learn how to conduct research in terms of defining your own problem statement, defining your objectives, looking at what resources are there for a particular topic that you're researching on, how to find those resources. Um, they say a word called Google Jutsu, right? So you need to know how to Google as well. It's not as easy as it sounds. Okay, you need to know how to report your findings in concise, technical manners. You cannot just keep on talking and talking and talking and write essays and stuff like that for a technical report. And you need to discuss them in critical manner. You don't want to be discussing the obvious, right? If I can see something that is there, what's the point of you explaining it to me? I can just read it, right? So what are you bringing onto the table? So all these things is what I hope that you will achieve if you do a successful job in this particular project. And in addition to that, since it's a data analysis dependent project, you will also learn, if you haven't had experiences before, how to gather your data, how to process it, how to curate it, how to analyze it, how to visualize it, and stuff like that. The basics of it. You don't need to go too deep about it, right? There isn't an emphasis on the analysis part, but what you get out of the analysis is what we will be evaluated, right? So if you even use the most simplistic analysis method, that's fine. You won't be judged by the complexity of the method that you apply here, okay? And again, this is a kind of like a cautionary note. You need to make sure that you don't slack off, okay? This work is intensive. I'm not going to lie about it, right? But it is not impractical. It just needs some effort, okay? If you stay on track sincerely, and if you meet time to time, maybe you miss a week or so because of some other schedule and stuff like that, that is understandable. But if you are away from work, without letting your group mates know for over a month, right, and you come back like 2 days before the deadline, you cannot contribute much. That is something that everybody can understand, right? So don't be that person that draws the ire of the rest of your group members and causes anxiety for them, right? Work with them. Everybody's human. Everybody has their own things going on, but you need to come together, communicate, and do your part. That is necessary. Some of you will be driven. Some of you will be passionate about this topic. They will need motivation, right? But if you are struggling and if you're having a hard time, then you will grow more frustrated easily. But you have to keep reminding yourself that if you stick to this, right, if you have faith in the process, then you will be able to see the outcome in some time, right? But you cannot quit in between, saying that, oh, this is too hard, this is taking too much time, I'm getting frustrated, let me just give up, right? So that is not going to help you. That is not going to help your group mates. So don't take others for granted. At least do your part, if not above and beyond. Okay, so that's the only suggestion that I will give you here, and I'm hopeful that everybody will do their part. Okay, but remember, please, you're not going to get a free ride. Even if this is a group work, there will be no free rides. There will be self and peer evaluation at the end. After the phase 1 submissions, I will be asking for the feedback of every group as to whether they are happy with the performance of the group members or not. Are there any issues and stuff like that? So if I find that somebody has not been contributing at all, I won't be hesitant to give them, less than the passing grades, depending on what the extent of the contributions are. So please do not gamble your luck, so to speak, on the hard work of others. That's the only cautionary trail that I will be kind of, talking about in this particular category. Okay, so the end goals, real quick. What I want as a client is to basically educate myself on this topic. I want to know what this topic is about. Assume that I have zero knowledge. Okay, so I want to know what this topic is about. And after I listen to your final presentations and I read at your final report, from a beginner's point of view, going towards an intermediate level, I have a better understanding of what your topic is about, what it entails, right? I want to know what are the pressing issues. I want to know what are the statistics around those pressing issues, what has been done, what is the focus, what is not the focus, and stuff like that. I want to know the focus. I want to know if the focus, according to you, is in the right direction. If not, what should be done from your side? Okay. I want to know, where did you gather your data from? What type of data is it? Right? Is it a policy document? Is it a white paper? Is it a research paper? What is it? Where did it come from? When did it get published? Right? Where did it get published? Who published it? Right? Those kind of things. Right? A summary of it. This is an analysis, remember. So you won't be giving me a list of it, but you will be giving me like a summary of it, right? Tell me about the methods that you use to analyze the data. What should I know about the methods, right? You need to tell me that, okay, for example, let's say if you use sentiment analysis about people's view about this particular topic, whether they feel too positively about it, do they not care, do they feel negatively about it, are they like, it's not an issue and stuff like that. Then you tell me that, okay, how did you do the sentiment analysis? What is your data set, right? How many data entries do you have? So that I can make sense of your data and connect it back to your method that, okay, this is how you got, right? You need to show me appropriate visualizations for analyzing your data. You need to look into government policy documents if there are any, okay? And then what do these policy documents focus on? Does the government have any role to play? Because some security and privacy policies are dictated by the government. If you want to check, you can, a case in point is the GDPR document from the European Union, right? So that's one of the most famous because this one has one of the most strictest data privacy rules. Privacy is not directly related to security, but it's like a close sibling of it, okay? So there are some topics that will also have government-related policies, okay? Not all of the topics, of course, some of them, okay? Tell me about the open-ended questions that are there in these topics. What are they, right? What kind of effort has been made to address these topics? What about academic effort to address these topics, right? Are there any publications? If so, how many publications? What are the topics regarding these publications? And what do they focus on, right? So this is the initial outline of the end, right? You can extend this, refine this further, and draw your own set of hypotheses, draw your own set of objectives that you want to analyze, okay? Not all of these will be equally applicable to all of the different topics and all of the different categories. This is just a generalized set of what a client's requirements could be with respect to this topic. And in this particular case, me being the client and my expectations from you regarding the outcome, right? So think along these lines when you start formulating your objective. Once you formulate this, essentially your problem statement, your objective will come into the picture. Then you will go into data gathering phase, figuring out the methods and then apply them, get the results, draw the discussions, right? So this is basically the curviest part of your learning curve, right? Once you overcome this, the rest of the stuff will become relatively easier. So this is where you need to use your topic system notes, right? So please keep that in mind. All right. So deliverables, essentially, you will have a single PDF document every time you publish your report, not publish, but submit. So phase one, you will have a PDF report, single column, one in margin, all sides, Times New Roman or Arial, 11 or 10 font size, okay? No restriction on page limit, okay? Again, there are questions here, time to time from my experience. It's like, oh, I wrote a 7-page report, is that enough? Does it convey all the information that you need to convey, or does it raise questions? Okay, so you need to be the judge of that, right? Not me. All right, I will directly evaluate. I'm not going to give you semi-evaluation like, hey, are you going to penalize me? Well, you submit the document, I will let you know if you will be penalized or not, right? But you can ask me feedback about the technical content, whether something is good, bad, can be improved, what to do and stuff like that, but not these questions, right? So you need to ask yourself that whatever report you have created, does it address whatever you wanted to address or not, right? That is important thing that you have to keep in mind. Phase one will be work in progress, so to speak. And what I want to see at the end of phase one is basically a problem statement, research objectives or hypothesis for your analysis, your data collection and their sources, right? All the data needs to be collected. And once that is done, the contents of phase two, which is basically going to be your data analysis methods, executed, results, and the conclusions for phase two, right? All in a single PDF document. Don't create 2 separate documents for phase one and phase two. And then after that, you create a short PowerPoint presentation, the same thing as you did for your research paper presentation task. Pre-record a video at the end of your project. Length should be around 40 to 50 minutes. no longer than 60 minutes. And then do the same thing for your hosting as we discussed in the research paper presentation task. Okay, so and please make sure that you submit all your code as a GitHub repository link that will be specified towards the end of your report. That's basically the deliverables here. Right? So that's all there is to the research project. Okay, if you have any questions, of course, feel free to let me know, discuss with me when I'm back in town, in person, or through office hours and stuff like that, and I will try to clarify whatever doubts you have. But first things first, please formulate your group. That's the most important thing. And then please decide on a topic. Don't wait till 23rd as listed in the Moodle platform here to submit your project selection. Don't wait till then, okay? Get a head start on this. The earlier you start, the better you would be, right? Because right now, the pressure is less as we move forward with the course. As midterms approaches, you'll have a lot of exams from different courseworks. The pressure will keep on increasing. You will have more and more assignments building on top of you. So this is the time to get that head start. If you work a little bit hard now, your life will be a little bit relaxed towards the end of the semester, and you won't be as stressed out as you normally would be if you chill now and then think of doing the work later, right? So that's my suggestion to you. The execution is up to you, okay? All right, so coming to the topic of interest. So the way I have designed this course is essentially as I said, we have 5 different modules, right? But the division of the coursework is the conceptual part of the course, which essentially talks about, or me discussing about, the background and the fundamentals of the computing architectures and concepts that led to the conception of cloud computing. Okay, and then what is cloud computing? And then once that background is done, and that will take about a month's time, then we will move completely towards learning about the Amazon Web Services or the AWS platform, right? And the way we are going to cover AWS is keeping in mind that there is a certification program from AWS that is known as Amazon Cloud Practitioners Certification, which is the very first certification that you can obtain from Amazon that shows that you are familiar with the different services that is provided by Amazon, okay, across all its different categories. So we are going to be covering Amazon AWS based on the preparation of that certification. So which means that at the end, once this course is done, if you want to sit for that certification course with a little bit more practice, you can sit for that. You don't have to spend hours and hours learning everything, right? So again, the module 1, module 2, and half of module 3 is designed around that conceptual background. So it's going to be dry concepts, okay? And we have to sit through a lot of fundamentals, a lot of concepts, terminologies, basics, and stuff like that. So try to keep your interest there. What is important is if you do not know the background, you won't be able to appreciate what is going on in the current day and age. So these topics are as important, even though if it's a little bit dry compared to the second half of the course, right? However, we will finish this topic somewhere around the mid of February. So it's not going to take more than 1 month, which essentially translates to about 8 classes, okay, give or take. And then once we get into the second half of module 3 from AWS Basics is where we will talk about all of the different things that is AWS, right? All of the different services that are AWS. So we will start from its compute cloud, okay? It's not Google, so you have to say the Elastic Compute Cloud, which stands for EC2. That is the processing part of AWS. So we'll start from there. We'll talk about setting up different network policies, talk about identity and access management, key generation, creating public and private clouds within AWS using all of these EC2 processes and stuff like that. And then we will move towards the storage and databases for EC2, right? The Amazon RDS and stuff like that. The simple storage service, which is S3. So we'll talk about that. Then we will move on to AWS DevOps, talk about domain name service, Route 53 for Amazon, particularly for hosting your websites, buying domains and stuff like that. Then you have content delivery, serverless computing, learning about Amazon Lambda, container services, using Dockers for Amazon and stuff like that. And then finally, I will just give a brief overview. We won't be demoing any of this because this is not pertaining to your cloud practitioner course very minutely. It's about the different services that are available to provide security on Amazon for all of these different things that we have discussed. So just to walk you through a little bit more in depth, is you will learn how to create billing alarms. You will learn about identity and access management on Amazon. You will learn how to create your own virtual private cloud. You will learn how to create security groups and networks for your EC2, public and private services. Okay. And then you will look into different things such as storage services. Okay. And then block storage. All right. How to create snapshots and stuff like that. Talk about the relational database in Amazon and the non-relational database, which is known as DynamoDB for Amazon. Okay. And then we will talk about how to perform automation on Amazon, which is done through the service that is known as CloudFormation. And then we will also be doing Elastic Beanstalk, which is another level above CloudFormation that increases the level of automation by a little bit more. Okay. We will look into how to perform continuous integration and continuous delivery for developing your application. So this is pretty good to know if you are going to pursue a career path in software development. Okay. We will learn how to work with code pipeline. Okay. And integrate that with the Elastic Beanstalk, which is again related to automation. So if you bring DevOps to automation, that increases the level of automation. Furthermore, domain name services, .53, as we talked about, how to upload or how to buy domains on Amazon and host your websites through Amazon by buying specific custom domains, how to create a CloudFront distribution to upload a static website through the S3 bucket and stuff like that, how to work with Dockers on Elastic services, and then how to use AWS Lambda, which is essentially pertaining to serverless computing, creating queue services, notification services for Amazon, and then integrating that with Lambda so that you get proper notifications and you can queue your different serverless logics together and execute that, right? So that will be the gist of all of the different functionalities that Amazon has to offer, and prepare yourself for the cloud practitioners course, essentially. Okay. And then security wise, we're talking about what is known as a shared responsibility model. Okay. When you work with cloud computing, when it comes to security, it's always about a shared responsibility model. The client has some responsibilities, the cloud has some responsibilities. So if you're working with the cloud, okay, as a cloud engineer, as a cloud architect, whatever it is, you need to know this model, right? So we'll talk about that. We'll talk about compliance, service called Artifact, okay, Inspector, the web application security, the web application firewall service, the Shield service, how to perform penetration testing using their services, okay, and all of these different kind of services that is pertaining to security on AWS for all of these different services that we're going to learn, right? So from February onwards, it's going to be demo after demo in every class. Once we start with the AWS basics, understand the architecture, but till before February, for the next upcoming 6 to 8 classes, it will be concepts. It will be understanding about, what is a distributed model, okay? What is distributed computing? What is centralized computing? What is parallel computing, right? Those things. What are computer clusters? How do you design computer clusters? What led to virtualization? How do you implement virtualization? What are the different levels of virtualization that you can do? And then what is a data center? What does performing virtualization on data center to achieve automation means, conceptually speaking, right? And how all of these things, right, all of these conceptual backgrounds and demands of the modern day computing led to cloud computing, right? Because we all talk about cloud computing. Some of you might be able to explain cloud computing, but can you relate that to the background? How did the evolution gave the rise to cloud computing and people came up with that idea, right? Because it is not built from scratch. It's built from something that already existed. So you need to learn that. When you're learning something from an educational perspective, you need to know that. So everything that you do after this, you can understand how it came to be and you can appreciate that. So that's the reason why we are going through this conceptual part first before we get into this implementation part after that, right? So that's how this course is designed, and that's what we are going to be looking forward to, okay, as we move forward in this coursework. All right. So with that, if I can only get the Zoom thing out of my screen. All right. So as far as the basic terminologies are concerned, this course can be wrapped up with this, not wrapped up, but introduced with this one single picture. Okay, because the idea was initially, before the internet kind of blew up the whole scenario, the emphasis was in high performance computing systems, right? So you bring these very high processing units, right? A lot of processing power, a lot of memory, right? To do very complicated tasks, okay? And it runs these tasks for days, weeks, sometimes even months. And these are mostly engineering problems, manufacturing problems, and stuff like that. Very complex tasks. And that's where initially the computing paradigm started, right? All similar types of nodes, okay, working together to solve one common problem, okay, which is very complex in nature. But as the internet came into the being, right, and as more and more services were being deployed on the internet. So take, for example, a very common service that we are familiar with, okay, which is web search or search engines, how it came to be. Like Google is there, Bing is there, Yahoo is there, still there. Well, you know. So that led to the rise of, that led to a shift in the paradigm from high performance computing systems, whose sole job was to just solve a problem taking a long period of time, then to support a lot of user requests in a given unit time, right? So that led to the evolution or paradigm shift from high performance computing to high throughput computing, where the idea is to serve as many as user requests as possible in a given second, in a given minute, right? So that's where the business needs started to shift towards, as more and more services were being uploaded and made available and dispensed through the internet infrastructure, okay, and through the World Wide Web, so to speak, right? So eventually, this HTC system then kind of evolved to what is known as the P2P or peer-to-peer network, right? And the focus kind of became on file sharing. How can we all crowdsource together to share all the different files that will be available over network, right? So if you have heard about things like BitTorrent, NewTorrent, LineShare, those kind of things, that was pretty old. So that was the example of services with respect to peer-to-peer networks, right? And then HPC systems kind of evolved into clusters of these computers. So you have homogeneous nodes for HPC systems, right? So when you create a cluster of them, then you can communicate between these clusters as well to kind of create more performance, so to speak, right? And all of these clusters, although they were separate, they had a centralized control, right? So these were all different clusters, but they didn't have their own autonomy, right? And the problem with this P2P network was these are where all distributed control, right? Everybody, let's say you have your own computer, I have my own computer, and then we all come and join this particular file sharing network. So nobody has control over others' computer, right? So there is no universal standardized policy to control if something happens. So if you have a rogue unit, if you have a malicious unit, so you wouldn't be able to control that. So they were all distributed in nature. So it came with their own pros depending on the service needs, and it also had their own cons depending on what kind of architecture they were following, right? So once the idea of this distributed P2P network and these clusters of multiple parallel processing units, okay, were brought together, that gave rise to what is known as computational and data grids. So data grids were formed through the idea of P2P. Computational grids were formed based on the idea of having clusters of multiple parallel processing units, okay? And from there, three different paradigms came up into the picture, okay? So the first one was the service-oriented architecture. The second one, through virtualization, was the Internet of Clouds, all right? And then through sensor technologies and RFID to a certain degree, came into being Internet of Things as well, okay? So from Internet of Things, you have also another sibling of it that is known as cyber-physical systems. But we will discuss probably in the next few videos the discussion between the difference between Internet of Things and CPS, right? But what you have to know is that when you apply the concept of services, right, or service computing on top of computational and data grids, that gives rise to Web 2.0 and above, and all these services that we use in the modern day, right? So right now it's no longer 2.0, it has crossed that, it's almost reaching 4.0 and stuff like that. When you apply virtualization, that gives rise to the paradigm of Internet of Clouds. Not yet cloud computing. There is one more feature that is missing here, which makes Internet of Clouds properly the cloud computing that we know, okay? But it's there, okay? Virtualization makes the cloud concept, so to speak, but not completely. Keep this in mind. And when you apply sensor technologies to computational and data grids, that gives rise to the infrastructure of Internet of Things, right? So that is basically the evolutionary background of the paradigms that led to cloud computing, right? It started off with one. The need changed as the business model changed, right? And as a particular infrastructure, which is the internet and the service on it, so the World Wide Web grew more and more popular. Then it morphed into something else, parallel computing versus file sharing, P2P network, that was again merged together, gave rise to grids, okay, computational or data grids, depending on the architecture. And then applying more features on top of these, three new paradigms came into the picture, right? So that is basically the evolutionary background of what we are going to learn, right? And we're going to learn these individual things like how to create these clusters, computer clusters, and stuff like that. So when it comes to the different terminologies, right? So we just discussed about the difference between high performance computing and high throughput computing. What you have to know is these computing paradigms that we saw here in this particular slide can be distinguished or characterized into four different categories, four different basic categories, right? So you can have centralized computing, where we have a single control authority and every other computer is controlled by it, and they're all tightly coupled, right? So they all share their resources, their processing and stuff like that, processing, memory, and computing. And it is controlled by this single entity, which you can call as the server, right? So the client server architecture is a very good example of centralized computing, at least the control part of it, not how it is implemented. That is a different story altogether, right? Then you have parallel computing, okay, which kind of overlaps with the next category that is known as distributed computing. And the whole concept of distributed computing is opposite to that of centralized computing, of course, right? That you have multiple different distributed computing resources, and they're all autonomous from each other, okay? So they don't get involved in each other's business and stuff like that. But parallel computing is basically different processes, okay, working on a particular task that has been parallelized, so to speak, based on these terminologies. And each of those processes that are running in parallel, they are executing on a portion of that task, right? And these tasks can communicate with each other through a shared memory architecture. So all of them are sharing a single memory. So that means the outcome of one processor can be sent to that shared memory architecture, and then the other processor can kind of read from that and stuff like that. Or they follow another architecture that is known as inter-message passing, right? Or inter-processor communication and stuff like that, which is very costly in nature if you're going to do that, because that kind of creates a latency. So people generally don't use that. Even shared memory architectures have their own issues with respect to security and stuff like that, even though they can speed up some of the processing, but they come with their own cons as well, right? And through all of this, by using all of these concepts, comes cloud computing, right? So it overlaps with distributed, centralized, and parallel processing. So it takes the best of all worlds and implements that computing paradigm, okay? So if somebody asks what are the different computing paradigms, then this is what we are looking at, right? So you have centralized, parallel, distributed, and cloud computing, right? So you can read through the discussion and definitions. So there are some terminologies that are within each computing. So for example, here, if you take parallel computing, this discipline is known as parallel processing, okay? And the systems which can execute parallel computing are known as parallel computers, all right? And then the programs that are running on a parallel computer are known as parallel programs. And the process of writing a parallel program is known as parallel program. So this is not something that will make or break you, but these are good to know historical things or basic evolutionary things that will help you move forward, right? These are all good to know. So read through them and understand them, and it might come in use sometimes later on in the future if you ever need. Okay, so what we are going to do is once we move forward, we are going to start discussing about these IoT and CPS, which is where the main emphasis is. That is, when you get to this computational grid points, how do we get all of these newer age computing paradigms, right? So that is what we are going to discuss in probably the next lecture, because we have discussed enough for this one video. So I will share another video after this, which will take it up from these just revisit some of these discussion that we made right now regarding the paradigm shift. And then we'll pick up the discussion from these differences between IoT and CPS. Okay, so I will stop the recording here, and I will see you all in another video. Okay, so bye-bye, take care.